We're at an automotive proving ground here to do some validation testing of our development vehicle. This morning we're going to be out on the high-speed oval checking for high-speed stability, wind noise. This facility also has a geometry track which has a very extreme up and down and series of curves, so we can check the suspension articulation, check the stability through sort of extreme maneuvers. And then we also have a NVH, noise, vibration, and harshness surface with a lot of different kinds of rough road surfaces. So we're able to check to see, how the car responds to those kinds of surfaces that you might encounter in normal driving conditions.
I think that having a mule car to test was exciting in that we finally get to do a validation of what we've been working on. We have to physically validate things, right?
The development mule is functionally representative of our production vehicle. It's the first physical prototype after the work is done in CAD. So we designed this car. This is actually the first car that we've designed fully in CAD. This is the first physical prototype. So we validate the work that was done in CAD, make sure that everything works together properly the way that it should before we actually go into production with a production level vehicle. It's really important to do this validation testing at this phase of the program so we can flesh out anything that needs to be addressed well before we go into production.
The testing of the mule vehicle went well. We didn't break anything, so that was good. The main points were, to kind of just have a total vehicle shakedown of the body in white, the chassis, the electrical system, and the cooling system, and to understand, are we going to overheat the car? Everything in it's new, down to the fan programming. What's the oil temp look like? What's the coolant temp look like? What does the intercooler temp look like? Is there coolant spilling out onto the ground? I can't even tell you how many times we've taken a car somewhere in the past during a development and just something goes wrong. It's just whatever can go wrong will go wrong. This time, we basically just did our testing and put the car back in the trailer and went home.
Testing the balance of the car on the skid pad, we should have some understeer. That means that the front tires are starting to break traction before the rear tires. And that's the most controllable condition because all you have to do as a driver is sort of back out of the throttle. That shifts weight to the front of the car and allows the front tires to regain traction. What you don't want to have is an oversteer condition where the rear tires lose traction first, because then the rear end will then step out or fishtail. That's more difficult to control. A skilled driver will be able to control that, but you actually have to apply more throttle, shift the weight transfer back to the rear of the car to regain the traction, which is not the intuitive thing that most drivers would naturally do. So it's really important when you're setting up a street car, you set it up so that it's safe for everyone that may drive it. If you're going to go out to the track, you might set up the suspension differently to give you a bit more speed in the corners, but that's really for an expert driver. So we noticed some binding in the steering during our testing. We think it might be attributable to a bracket that we installed yesterday in preparation of coming to the track, and that might have caused the steering to bind. So we'll just come into the garage and make a few quick adjustments, and we'll be back out on the track shortly.
I was, nervous. I was like, either it's going to perform better or it's going to be not working at all. And I'm going to hear about it the next day, So I was just like, oh, I hope that the car ran well. To my understanding, it performed just as well as it did on our current production, 1967, 1968s. That apparently it's much better at returning to operating temperature after being run hard. Its ability to return to stable levels is much better than it was previously. That's actually because when I was speccing out the fan for current production, I went with the Dark Horse fan. That's the higher performance variant of the Mustang. It's a much more powerful fan. We ran the specs on it. It puts out a lot more air movement. In conjunction with that, it also has more cooling capacity. It's the same size as what we were using before, so it's just going to work better. And because of that, it's able to bring the temperature down faster. The new fan that Ford just came out with uses a variable speed control. So now I kind of added to the luxury component of it. If you have your AC on, you don't hear your fan turn into this roaring gust of wind when your car stopped. It just kicks on very gradually and only goes as fast as it needs to because it has a million different speeds to pick from instead of just two.
Performance is really important. but really reliability is the key. You have to have a car that you're confident in. You can get in it at any time, go anywhere, and you don't have to worry about it. And that's what the purpose of all of this testing and development is, to make sure that our customers get a car that's fully sorted and doesn't have any kind of reliability issues. Of course, it's fun to drive, it's extremely powerful, it handles great, very confidence inspiring, but that reliability is absolutely critical.
The next step right now is final interior validation and aesthetic sign-off. So, we've got the base design down for everything. We just need to get all the interior parts in the car. We need to finally review all the interior parts for fit and finish, manufacturability, quality, reliability, durability. Just make sure all the interfacing parts, they're put together within tolerance, that there's not some unusual gap somewhere. It's really just heavily scrutinizing the interior, and that is the final step.
It was a great test day today. We found a few things, nothing major. I wouldn't say we found any surprises. It's important to flush these kinds of things out during the development process and not find them later. And that's why we're here. That's why we're doing this early. That's why we put together this development vehicle specifically so we could test all the functional elements of the car in a harsh environment and make sure that everything works properly before we go into volume production. And the point of all this is to take all of these learnings and to feed that back into the product development process to make sure that the finished product is as good as it can possibly be.